Good morning, good afternoon, depending the time you are seeing this video. Now, in today's tutorial, I'm going to talk about the base angle of an isosceles triangle. The base angle of an isosceles triangle. Okay. Now, this diagram here is an isosceles triangle because it's only two sides that are equal. That is why I take this. This is an isosceles triangle. Now, one of property of an isosceles triangle is that two sides are equal, two opposite sides are equal, and two opposite angles are also equal. That is the only two properties of isosceles triangle we have. Opposite angles are equal, and the opposite sides are equal. And it's only two sides of an isosceles triangle that are equal. You can take this down on a paper. Okay, the base angles of an isosceles triangle are equal. That is the theorem. I repeat myself. The base angles of an isosceles triangle are equal. The base angle of an isosceles triangle are equal. Remember, this is A and this is C. So this side is opposite to this side. And we can prove that this side is opposite to this side. Okay, there is a proof to show that A is opposite to this side, and also this side is opposite to this side. Let's see what we can do. Remember, the theorem states that the base angles of an isosceles triangle are equal, and I told you earlier that this angle, this shape here is an isosceles triangle. Okay, now let's try to. It is given that triangle ABC, okay, in which line AB is equal to line BC. What do I mean by that? Now, this is a triangle given. Check that triangle, you will see that this is ABC. That is why when you see something like this, this represents a triangle, right? This shape represents a triangle. So if I write something at the top, like if I say this is angle B. So if I write something like this is line B. If I write something like this is triangle B. So no differences between these two things, right? So that you'll not be confused. This is triangle B, this angle B, this is line B. So as we proceed, you come across this. Okay. Now, given that triangle ABC in which line AB is equal to BC. Now look at this. That's why I take this. See, I see BA or AB is equal to CB or BC. They are the same size. Now, since they are the same size, that the opposite angle are equal. That's the base angle. Sorry, it's not opposite angle, it's the base angle. The base angle of this isosceles triangle are also equal, since the sides are equal. Now, to prove that angle A is equal to angle B. That is what we have to prove today. I'll give you one example to solve on this. So let's try to proceed. Now, to prove this, draw a bisector of angle B to meet AC at D. What do I mean by that? What is a bisector? A bisector is a line that divides any shape into two equal. As you can see, a bisector of B to D. Now, the line produced from B to D to give a new point D. Remember that this AC can also be called as D, because when the bisector is drawn from the point of B to this point, that means it produces a new point, and that new point is called point D. So I can represent point D with AC because D is between A and C. So this is a new point that is from this triangle and produce to point B. Hope you are getting me. So this line from B to D is a bisector of this isosceles triangle. Sure, you're getting me now. Now you can choose to draw this triangle into. If you divide this triangle and you draw it separately, you are going to have something like this. You are going to have that. You have something like this, right? Let me have something like this, right? You also have something like this. If I don't know how to, I don't know. So that is that. So if you divide this triangle into two equal parts, I'm going to have something like this. Now, this is point B, this is point D, and this is point C. So call this B, call this A, and call this D. Are you getting me? So they are the same. They are the same. Are the same. These triangle are the same. Though it is not called a isosceles triangle anymore because it is divided into two. This is called right angle triangle. Remember, if you come two right angles together, you are going to have what we call an isosceles triangle. If we join this triangle together, we are going to get an isosceles triangle. So if we divide an isosceles triangle into two equal parts, one triangle will be called right angle triangle, and the other side will also be called a right angle triangle. So if you combine two right angle triangles together, you are going to have what we call an isosceles triangle. Hope you are getting me now. From this drawing that separates this from here, I can now confirm that line AB is equal to line BC. This is equal to this. So that means this is also equal to line BD is equal to line BD. I will explain. Because they are what? The same size. Because they are the same size. What do I mean by the same size? Now, since I have divided this triangle into two equal parts, remember this is still point B to D, and this is still okay, this is C, sorry. This is point B to D. This is point B to D. So that is why this is equal to this same size, since I have divided this into two triangles, and we still have BD and BD. So I can this equal to this is equal to BD because they are what? The same size. If and only if I am divided this isosceles triangle into two equal angles, which is a right triangle. Hope you are following me up to this point. Okay, since we have this, so what next? We can say that we can therefore make a complete statement. We can say therefore triangle B, yes, triangle B AD, yes, triangle BAD is equal to triangle A. Is it A? No, it's triangle BCD. Yes, angle BCD. I will explain that. Where is that cover? Now look at this. Now triangle BAD is equal to triangle BCD. This BCD. So this side is opposite to this side. Okay. Now I can now confirm that angle A is equal to angle B. So this is out. I want to prove that this angle is opposite to this angle, and that is the proof. Remember, this theorem statement, you can write it down. It's very important that you can apply in any way where you come across such a problem like this. And the theorem states that the base angle of an isosceles triangle are equal, and these are base angle and they are equal. So if the base angle of this and isosceles triangle are equal, also line AB is also equal to line BC. And remember, a bisector is drawn from the point of B to this. So that is where you establish a new point, which is D. And earlier that this point D can also be called AC because it was produced from point B to D, which is from a new point. So I can call this point D instead of AC. I can also call this point AC instead of D. And I told you that the line drawn from B to D is a bisector of B to D. And a bisector is a line that divides two shapes into two equal parts. And I draw that two equal parts of an isosceles triangle, which we have a right angle triangle and we also have a right angle triangle. Remember, in right angle triangle, none of the sides are equal. We have the hypotenuse, we have the opposite, and have the adjacent. Okay, so I'm going to give you a problem to solve on this. Now remember that the sum of angle in any triangle is equal to 180 degrees. Okay, so that is how the theorem of an isosceles triangle is being proved. Thank you. Let me give you work example on this for more understanding. Thank you.